Hello, and welcome to this lesson on errors. This is part of the course Python for Beginners. My name is Buddhika Karunaratna. I am from the University of Morocco. As you have probably experienced by now, it is quite normal to get different kinds of errors while programming in Python. So in this lesson, we are going to get a formal introduction to some of the basic types of errors that we encounter. This is the regular color coding used in this presentation as well as all the presentations in this series. We can identify several types of errors that we encounter in programming. What we usually call as syntax errors, they are mistakes in using the programming language. Each programming language has its own syntax, and we should be very careful and we should write our programs correctly. And then we have runtime errors. Those are which occur when a script or a function is executing. These are sometimes referred to as execution time errors. And we will soon see some examples of these. And finally, we have logical errors that would not generate any error messages, but they would result in unexpected or erroneous output. So, what are these syntax errors? Let's take an example. Look at this print example. We are trying to print the string hello world to the console. Did you notice something wrong? You can take a moment to observe. So what will happen if we run this code? You can see that it generates a syntax error. We were trying to print a string value and Python was expecting single or double quotation marks. But we mistakenly had one quotation symbol missing at the end of the line. Because of that, Python is complaining about a syntax error. Now we have some idea of what a syntax error is. Now let's look at runtime errors. Runtime errors occur whenever syntactically correct Python code results in errors at the runtime. So there will be an error message telling us what went wrong. And it is important to know that whenever a runtime error occurs and it is not handled properly, your Python program will terminate after that point of error. That's the problem. Meaning the program will not continue to execute and you will not be able to get the expected task done. There are many types of runtime errors in Python. We will look at some of the common types in the next few slides. Let's first look at what we identify as a name error. A name error usually occurs when you try to reference a variable that has not been defined previously in the code. So we have an example. In this example, you see a variable named number with value 10. Then we try to print the value of a variable named num num. Notice that our original variable name was number, but we are asking Python to print the value of a variable name num. Therefore, Python is complaining about a name error. And it says name num is not defined because it was not previously defined. So remember to avoid this kind of mistakes. If you get a similar error when you go ahead and do some programs, now you can look for some error which is probably related to naming and referencing variables. Now let's look at index error. This happens when we try to access a value from a sequence, but the referenced index is out of range. We have an example. So here, my list only has 3 items. And the index of my list is ranging from 0 to 2. But we are trying to access the item at index 10, which is not available. So that is why Python is raising an index error. It is complaining that there is no item at the selected index. Moving on to type error. So this kind of error occurs when we try to perform an operation on variables or objects of inappropriate type. So at this point, you understand what the type of a variable is. So in this case, we are causing a type mismatch. In the example given, we are trying to perform the plus or addition operator on a string and an integer. Therefore, Python is complaining that it can only concatenate. So what is that? What is concatenate? It means to join a string to string, but not any other data type. In this case, we are trying to do that with integer. This is just one example, but you may encounter many other similar situations when you program with Python. Now let's look at what we mean by a value error. A value error occurs when a built-in operation or a function receives an argument that has the right type but an invalid value. So in this case, in this example, we are trying to print the value of an integer but passing the string value hello to the function int, which is invalid. So that is why Python is complaining about a value error. Lastly, we will identify what is known as an import error or a module not found error. So in this example, we are trying to import a module named new module, which does not exist. Therefore, Python is raising a module not found error because it's not there. Similar error could occur if you try to import some function inside the module. The module could be existing, but that function or the part that you are trying to reference within that module does not exist. In such cases, Python will generate this error, which is module not found error. As we have discussed before, when a runtime error occurs, the program will stop immediately if the error was not handled properly. Therefore, you need to plan carefully to catch any of these possible errors during runtime and handle them. That way, you can keep an uninterrupted execution of your program. In the next section, we will see how to handle such situations. The try except structure helps us to handle possible runtime errors. It does not mean that we can prevent the errors. Instead, it creates a safe passage for the program in the case of a runtime error. We can basically identify 2 blocks. They are try and except in this structure. We can put the so-called dangerous code into the try block. That means you are anticipating an error in that section of the code. That's why we call it the dangerous code. In the case where the error actually occurs, the program jumps to the except block and executes what's inside that block and moves on with the program. However, notice that if we did not use this error handling structure, that program will terminate as soon as the error occurs. We don't want that situation. We want to avoid such situations. So that's why error handling is very, very important. Now we look at a simple example of this try except structure. In this program, we are expecting a number as input from the user. Once some input is provided, the program will try to convert that into an integer value. Notice that it is actually the risky operation. Why does it become risky? Because we cannot guarantee that the user will provide a number. For example, the user can provide a string or just input nothing at all. So in such case, the program will have a problem converting anything other than a number to integer. In normal circumstances, the program will complain about this issue and immediately terminate. But in our example, in such a problematic situation, the program will jump to the except block and assign the value -1 to the variable num_var. So it will prevent ungraceful termination of the program. This is how you use try except structure to handle possible errors. That is the end of the lesson on errors. I recommend you to try out those examples that were provided in this section. In the next section, we will discuss about files and how to handle files in Python. Thank you.